Okay, we're talking about section 5.5 now, the last section. Yay, I know you all are just so excited. So in the last section, we're looking at the same thing as 5.1 for the solution to a system where you graph would cross. But this time they're not just lines, they're lines and circles and alters. So they may cross in more than one point. As we can see on this first problem, they give us two equations, and the equation is actually the graph of a parabola. We know when x is squared, y to the first x squared makes a parabola shape. So they've got that graph for us and then a line running through it. Now sometimes the line totally misses it and there's no solution. But in this case the line goes right through it in 2 points. So there's two corresponding intersection points. So there's two solutions, two coordinates that solves both equations. So they ask you to verify those points, and how would you do that? You would plug them back in and make sure they work. So they have you demonstrate, say we're checking the point 417. 4 is x, 17 is the y value, in xy order. So in the first equation, we type in 4 for x squared equals y. It says is 17 minus 1. Let's see if it works. So that'd be 16 equals 17 minus 1, and yes. Check, that works. Then we have to check it in the second equation, 4 and 17. So y would be the 17 equals 3 times the x value, 4, plus 5. Is 17 equal to 12 plus 5? It sure is. Then we have to verify the other point in both equations. So again, that's the xy coordinate. So we plug in -1 for x and 2 for the y. So that would look like 2 for y equals 3 times the what is x? -1 plus 5. Is 2 equal to -3 plus 5? Yes, it is. Looking like this is going to work. And then we check it in this equation. Oh, I'm sorry, 4 and 17. I skipped that one. 4 and 17. 17 again is the y value equals 3 times that x value is 4 plus 5. Same thing there. I think I checked in the wrong one. All 4 need to be checked. Sorry about that, guys. I think I forgot. What I didn't check was 417 in this first one. No, I did that. And then shoot, haven't I checked? You have to check both of these in all of the equations. So let me back up here. There should be 4 checking points. I've checked did this one, and then checked in the equation. Then I was doing this and this equation, guys. Oh, here's what I haven't done. Not my bad. I have this in the first equation. So x is -1. So -1 squared equals y, which would be 2 minus 1. So -1 squared is +1 equals 2 minus 1. It sure does. Okay, sorry about that. Took me a minute to get that straight. Okay, so you're verifying points. The rest of the problems, though, you're actually just trying to find the solution yourself. What is the solution? Where would these equations intersect one another? Which you may be able to do by graphing. It's a little harder to graph the non-linear equations, though. So, but it's possible. Anyway, there's two other methods besides graphing. There's the addition method, which this is looking good for this one. I could add those equations and the y's cancel out. Or there's substitution. That would also work here. I'm going to do addition, though, since this is just ready to roll there. But notice in this addition, x squared and 3x are not like terms. So when I add, it'll just be x squared plus 3x. They don't actually combine, right? But the y's cancel. And 0 and 18 is 18. But that's okay because we know how to solve quadratic equations. Oh no, they're back, right? Quadratic equations, we get it on one side equal to 0. And then you solve the quadratic by either factoring or the quadratic formula. This does factor into +6 and -3. You set each factor equal to 0 to solve with this method. You get -6 and 3. So that's what's new in this section. There's more than one x solution, maybe more than one, even multiple solutions. So we have 2 values for x. So we need to, one at a time, put them back into the equation and find their y counterparts. So I'm going to start with the -6. Back to the, let's do the linear equation. They're always easier to deal with. So I'll plug it into this second one. I'll plug in x is -6. That's -18 plus y equals 18. thrown across the line makes plus 18 or 36. So when x is negative 6, y was positive 36. There's one solution. And then, if I plug it into the other equation, by the way, you get the exact same result, so no worries there. Just like what we did in the last section. Now I go with the positive 3. And again, you could enter either equation you feel like. To do the second equation. The first equation may have actually been easier on this one now that I'm looking at it. But no matter. 3 times 3 is 9, plus y equals 18. Throw that across the line. Y equals 9. So when x is 3, y is 9. So two solutions, two intersection points. We write both of those in the solution set, maybe with a comma between them. All right. Next example, we've got number 3. And I'm also going to use addition method here. See how that would add out so nicely. When I add these together, that cancels. And actually, this one, I can add those together. They are like terms. I'll get 10x squared. So it might be even easier than the last one. 10 and 0 is 10. Divide both sides by 10. X squared equals 1. Now, this is maybe a new thing, though. When I square root this, we haven't done this in a little bit. When you take the square root to solve, you have to say plus and minus of the root. So there's two solutions. You know, for quadratics, we should have two solutions. So it's plus and minus of that square root of 1, which is 1. So we do have two x values to plug back into the original problem, and you pick either one you feel like. I'm going to take this second one for no special reason. And I'm going to plug in positive 1, just one at a time. I'll plug in positive 1 for x. And 1 squared is 1 times 4 is 4. Throw the 4 across the line. Divide by the negative 1. We can have a negative sign in front of that. So y squared is 4. Now again, when I square root to solve, I need to say plus and minus. Plus and minus 2. So by putting in positive 1, I added 2, and positive 1 gave me a negative 2. So I've got two intersection points so far. Now I still haven't plugged in this negative 1. But notice, if I go back through my process, and I make that a negative 1, and I do work again, I would get this same result, because a negative 1 would still be positive 1 times 4. Same result. So I get plus and minus 2 that goes with negative 1 as well. So I've got negative 1 goes with 2 and negative 1 with negative 2. So there's a combination of 4 different points. When you write the solution set, all 4 of those points solve each one of these equations, and that would really get me in trouble if I try to remember. I have to check this one and this one and this one. Check this in both equations, this one. I'd have to be real careful, right? But all 4 of these points, when plugged back into each equation, so there'd be 8 different checkings there, with work. Probably see that in sleep. So then square rooting that to solve is 8, and don't forget it's plus and minus 18. So when I plugged in positive 3, again I only plugged in the positive 3, just focusing on that for the moment. Positive 3 gave me 18, and positive 3 gave me negative 18 for the results, right? Two y values from that 1x. Now I plug in the negative 3. So if that would have been a negative 3 when it was squared, I would get the exact same answer. So negative 3 also nets me a positive 18 and a negative 18. So again, with the 4 solutions for that. So those are all valid solutions for both of these equations. And if they were graphed, they intersect in 4 specific points. All right, number 5, and then we'll take a break and do the others on the other video. On number 5, I can't just straight up add these together. I'll have to do my manipulating, either make these both 20s or make these both, say, 63s. You're looking for a common multiple, so when you add, something will cancel out. So let's see. I want to stay with these smaller numbers. I'm going to make both of these into a 20. So I'm going to take the first one times 4 to make that positive 20. And the second equation times negative 5 will make that a negative 20. And then you have to do that all the way through. Whatever you choose, you do it by every term. So I've got 20x squared, 28y squared, and then 4 times 0 is still 0. For the second equation, negative 5 times every term. And then, of course, when you times by 0, it's still 0. Well, now when I add these two equations together, the x squareds cancel. You need something to cancel to use the addition method. So then we got negative 28 and negative 45. We add that together. It's negative 73y squared equals 0. Oh, but you know, when we divide, we're going to get 0 anyway. 0 over anything, 0 divided by anything is 0. When we take the square root of 0, we would say plus and minus, but there is no plus and minus of 0, so it's just a big O. 0 is the solution there. Now we need its x counterpart, so we go into one of these, any of these former equations that you like. I'm going to take this one in the bottom, and we're plugging in y is 0. So we get 4x squared plus 0 equals 0. So 4x squared just equals 0. Divide by 4. Oh, well, that's just 0 too. There's not all those plus and minus combos because of our 0 solution here. So that should be our one and only solution because of the 0 thing happening. There's no plus and minus. It had the potential to be a 4 solution type of equation, but because 0 doesn't have plus and minus, we just have the one answer. And you can look, times 0 minus this times 0, that definitely works there, and then also here. So that is our solution, just 0, 0.